So let's start solving those calculations there. So we'll be fast so that we'll just dismiss at exactly 4. What of mass? Mass Atoka is supposed to be here before me, but if he's not here, we believe he's coming or he's the family. Yes. So read, there's a picture I posted there. There's a picture I posted on Chevy ladder, leaning ladder that is having friction. So read the question, let's start because I'm recording it so that we work with the time frame. So read that question out.
I will finish up that yesterday.
I will finish it up, but I will come to that. Once we finish this one, we'll finish up that yesterday. So I have reason why I want us to point to this one before that one. So I use this one to understand the basic concepts that revolve around that. So just so you will see. Read that picture posted on the frictional wall. You see it? The letter of mass,
And with a length.
A letter of mass, The one that you know I posted PDF this morning as a picture. Then read the question of that picture that I sent.
The letter of mass and length.
A letter of mass and length. Okay, a letter of mass and length. Okay, leaning against the wall is like we are tired.
Yeah.
Against the wall.
The coefficient of friction at the base.
Coefficient of friction at the base. 0 point. Okay.
Coefficient of friction at the wall.
Coefficient of friction at the wall is equal to what?
0.35.
Okay.
Determine smallest angle at the ladder.
Determine
Smallest angle at the ladder.
the smallest angle
That the ladder can make.
that the ladder
Can make the ground same mistake.
is that all?
Yes.
Okay, please check if what I have on the board is the same with what you have, please. Okay, there's a letter of mass and length leaning against the wall. Full stop. The coefficient of friction at the base, that is coefficient of friction at the ground or with the horizontal, is 0.45. The coefficient of friction on the wall is 0.35. Full stop. Determine the smallest angle that the ladder can make with the ground and still be stable. Okay. So let's just analyze this English. Let's draw. So first of all, I have my wall. And let's say this is my ladder. Let's say this is my ladder. And let's say this is the ground. Let's say this is ground level. So if this is ground level, there is an angle. Yes, the angle that the ladder can make with the ground, which is theta. Yes. I will not rush to this, so you need to pay attention. Then, to be stable. So now notice something. If this is on the ground, there will be friction acting this way, shall we? Yes. And this friction is called friction of what? It's frictional force, yes, but it's friction acting on the ground, and it's not true. Yes. Let me call it Fg. That is frictional force, FFG, sorry. Okay, now there will be a force acting this way, is it not true? Yes. Another name for this force, naturally, as this ladder is acting on the ground, that was, this force that is going upward is called normal reaction, is it not true? Yes. So let me say this is Fn. Today's own, I said I will be using the words, the right words for it, so that there will be no confusion. We'll do it once. No questions. Now, yes, this is still the wall. Now notice, as this ladder is resting on this wall, there will be a reaction on this wall, back, giving it back. Is it not true? Yes. Let's call this force on the wall, or force of the wall, force of the wall, the force that the wall is giving. Now notice something. I want us to pay attention to an extra detail. Because I went home and tried to analyze all the questions we solved. Notice something. As this ladder is leaning on this, if they say it's frictionless, it means that it has that possibility of this sliding and falling down. Is it not true? It will fall down this way. Is it not true? But if they say it's frictional, it simply means that the possibility of it falling down this way is high. It's less. Shebi? Which means that there will be a force acting on it this way that wants it not to fall down. So let's say our frictional force is going this way for this. So now let's say this is no longer the self-friction with the ground, but rather frictional force of the wall. Are you seeing it? Now that we're analyzing these things, call me back now if there is confusion. Not when we've gone far. You want me to come back? Okay. This one, Shebi? Yeah. Notice that if I have, for example, this is wall. Let's say this is wall. This one is wall. Let's say this is the ladder. They say it's frictionless. It simply means that if I make any mistake, this thing can slide down. But if they say it's frictional, it simply means that even if I make mistake, when it wants to slide down, there will be a force that is pulling it back. Instead of if it wants to go this way, there will be a force trying to pull it this way, so it remains that balance. So that is the force I identified here, which is the frictional force of the wall. Okay. So now, another thing I need to identify is the ladder itself. It will have a weight. Is it not true? Yeah. And we know that any force acting on the body vertically downwards is called weight, not tension. Which means that this is going to be my mg. Very important. But let's check if there are things that we've not included. So that means all the forces acting on this. I think we have all the complete forces. Yes. So please, which means that yesterday's class we failed to include something. Because you know that sometimes when we finish a class, I will always go home based on our arguments from class to check if everything is in order. So when I went home, I realized that this particular body, when we said friction, that this body, there will be something this way and there will be another one putting it this way. Which means that once it's frictional, we must add this extra force. But when it's frictionless, we have no business with this extra force. So that means that there are two ways of looking at this question now. A linear ladder static equilibrium problem. When it's frictionless, we have no business with this. When it's frictional, we must have this. Okay.
But when it's frictionless, we have the one with the downward force.
Is it this one?
No.
That's this one.
Yes.
This one, it will always be there. Remember that the reason for all this friction we're introducing is simply we are looking at the ladder. On the ground, naturally, this ladder will want to go this way, but because of friction, for it to be standing, it simply means that there's some. In fact, for example, if you pour oil here on the ground, it's a smooth ride, you pour it here. No matter how you try to place this ladder and leave it, it will slide. Is it not true? But because that ground is okay for it, friction is there. So when you put it, it's not sliding. That means that there is friction going this way. Now, the situation where they tell you that now this side is frictionless. It simply means that any opportunity this gets, because of the angle, it will just slide. But when they say it's frictional, it simply means that no matter what you do, it's not sliding, which means that there's a force activity. So if I know this, that means that you now have two things at hand whenever you are giving this kind of linear ladder question. When it's frictional, you are looking at this diagram. If possible, you snap it and note. Why, when it's frictionless, you are just looking at it this way, in the way that you just have this this way, that is Fn, FFG, your LG, and just this one. So if it's frictionless, this. If it's frictional, this. These are the two. Which one? This one. Normal reaction, it's a normal force. So I'm using F so that in each case, when I'm using F is so that in each case I'm able to differentiate forces and weights. That's why I put weight as mg. And then I'm putting all the forces as F. Now let it be carrying what it stands for. Okay. So now that I know this, remember this is what the one we are treating. So let's now see how to get the angle there. Let's see how to get the angle. So now notice that if I'm getting the angles, they give me frictional force on the ground, shall we? And they give me frictional force of the, coefficient of friction, static friction on the ground, and coefficient of static friction on the wall. Now, please, we need to remember that first of all, frictional force is given by coefficient of static friction and normal reaction, shall we? Yeah. But in this case now, which means in these two cases, frictional force on the ground will simply be the same thing as saying coefficient of friction on the ground and then this force. Should you remember? That is normal reaction, which is this force now. See, I have this friction going this way. So what are the forces? What are the forces that are, what is the force acting? Is it not this force? Should be? So the coefficient of that friction, that is the coefficient on the ground, and this force that is here, which is Fn. So you need to be identifying. Friction does not just work on its own, it's looking for the force that is there. And if that is the case, the force that is here is this force acting upward, giving it back this way. There's not tell us that there's any force. This particular force that I have here, there's not tell us that there's a force that is taking it this way because it's not sliding. So this is the only force that is available here. So the same thing. That means that frictional force on the ground is the same thing as, okay, let me write it, Fn. Now let me check for frictional force on the wall. That is this frictional force. What are the forces here? That is, removing your eye for frictional. What is the other force there? Fw should be? Yes, frictional force of the wall. What other force is here? Like force of the wall should be? Which means that frictional force of the wall should be equal to coefficient of friction on the wall and force of the wall. So we've noted all those things. I don't have to put this one. I just use this one to remind you what friction is all about. The formula. Okay. So somebody asked me yesterday, what of a situation where we don't have to use torque? Why are we always using torque? So today's class, before we think of torque, I want us to use the 3 principles. That is those equilibrium principles where we talked about up and down forces. Do you still remember? Then horizontal forces, clockwise and anti-clockwise, before we then talk about torque. So let's apply all these things now. So now let's check, what are the forces upward in this? The upward forces, what are they? Frictional force of the wall, frictional force of the wall, normal force, shall we? You see that the two are acting in the same direction. And when you're going this way, it's y. So that means that it's all positive, Fn, okay. Now, I know that upward force is equal to downward force. So it will be equal to, what is the downward force? Mg. Okay. Now, on the horizontal parallel forces, the horizontal forces will be equal. That is clockwise equals to anti-clockwise. So if I check, what are the clockwise and anti-clockwise forces here? Force of the wall, shall we? And this one, shall we? So it will be equal to frictional force of the ground. Is it true? Okay. I just want us to be checking all these things out first. So we've been able to pull out upward equals to downward. Upward equals to downward. And we've been able to pull out anti-clockwise moment equals to clockwise moment. Okay. Two things. Okay. Now, I want us to check again. If I choose to look at this frictional force here. If I make Fw subject of the formula here, what do I have? Let's say I make Fw subject of the formula here, what do I have? Should you know it's normal? Are you aware it's normal? That time we have frictional force equals to this, we can make the force subject of the formula. We have that the frictional force will be divided by the coefficients. Do you still remember? Let me just check. So if I make Fw subject of the formula, I will have Fw divide both sides by mu W. So it's going to be Fw equals to frictional force of the wall all over coefficient of friction on the wall. Is it not true? Then if I choose to make this force subject of the formula, it simply means that I will have normal force or normal reaction will be equal to frictional force of the ground all over. Okay? Should you understand this?
No.
I'm making force. So frictional force is the subject formula here. Is it not true? What of force? Frictional force is force opposing motion or opposing force. So what of force itself? Because I know that they've given me mu already as 0.35. So if I make force under the formula, this is what I have. If you don't understand it, from this equation, make this one subject of the formula. That is what you will have. From this equation, make this one subject of the formula. Get what you have. That is what we are doing. So once you've done it, that means we've gotten, applying the principles of equilibrium, we've gotten upward and downward force, one. We've gotten clockwise and anti-clockwise force. Is it not true? Now, we now want to do torque. Do you still remember those three principles? So please, I want to do that one here. Or let me do it here.
Now wait.
You must be fast. So see all the steps I'm taking. The first step for, that's my equilibrium, upward, downward, then clockwise, anti-clockwise. Then I got what friction is. Then when I got friction, and I said, okay, since friction is force opposing motion or opposite of force, what of force itself? So I made force. And the force that I have in this case is force of the wall. That is from here. Then the force that I have here is normal force, so I got it. So it's more like I need to get all these things and be sure that I'm not missing any step. So the third one now, which is the last one, is to apply the principle of torque. That is, sum of torque must be equal to 0. So applying that principle of torque, I just want to clean this part small. Or I can do it here now. Okay, so let me do sum of torque number 3. Sum of torque, that is clockwise and anti-clockwise torque must be equal. Sum of torque must be equal to 0. Alright. So if I'm taking my torque, if I'm getting my torque, now remember there is a principle we normally use for our torque. Is it not true? I'll make one part my fulcrum. So notice, already I'm having problem already. I have 2 unknown forces up, 2 unknown forces down. Is it not true? Yes, I'm having frictional force of the wall already. Then I'm having frictional force of the wall. Then I'm having frictional normal reaction. And I'm also having frictional force of the ground. Yes. So please, for the fact that what we are doing here is trying to perfect our knowledge, I want us to stick to what we already know. Let's direct all the forces here to this side. Let's point all our forces to this side. But you, as we are doing the same principle we've been using, that is when it's tall, pointing all the forces to this, and you're mastering and getting used to it. It's now up to you, maybe when you get home, to try and see what if you point all the forces from here to this point. Or maybe what if you point all the forces here to this one and point all the forces to this. Okay, so that if I'm checking it now, if I'm pointing all those forces, that means that here becomes my fulcrum. Please, once, this one should not confuse you because I'm using the same thing we'll be using for the torque. So that means I will not have anything to do with all the forces here. I'm channeling just this force to this force to this, and this force to this. So let's do it so that I'll now have FFW. And you know that when I'm doing torque, it's no longer FFW I'm using. Right now I'll be checking, this thing is a vertical force, is it not true? And vertical forces become what? Vertical force is, we run it with cos, is it not true? Yes. While horizontal is what? Sine. So vertical becomes FFW cos theta. And remember what torque is. Torque is simply force times distance. Yes, and we know it's perpendicular force times distance. So that is why we are taking this to this company. If we start doing it again, that requires you going to study because we've done it over and over. So I'm just putting FF. Once you stop, just know that you are taking whatever you have. If it's y, call it cos theta. Whatever you have, add cos theta to it. If it's x, whatever you have, add sin theta to it. So FFW cos theta. Now, what is the length of this from this end to this end? L. Is it not true? So I will now have L. Okay, now plus. Why am I using plus? Yes, why I'm using plus is because I've noticed already that this thing is going this way. And this one is also going this way. Is it not? They are going in the same direction. And this direction that they are going. Remember that when I'm doing clockwise equals to anti-clockwise, no need putting the signs. Unless I want to make everything summed up one side and now point it to equals to 0. So this is anti-clockwise. And this one is also anti-clockwise. They are going in the same direction. So I'll add it up. So FW. This is x-axis, Shebi. So it will carry sine. Sine theta. What is the length from this end to this end? Is it L over 2 from here to here? L. Because you know that this is the same point, Shebi. So L is equals to 1. This is the next force, right? Now, why I'm doing equals is I've already seen that this one is going this way. Notice that this thing here is the same as saying, and notice that it's going to be, so it's going to be going this way. Why this one now? This one is going this way, to this, to this, to this. And the same thing with this one, to get to a point where it turns to this. So you see it's different direction. So I'll simply have that what I'm having here now is going to be mg. And because it's going in the vertical direction, it's going to be cos theta. Now, what is the length from this point to this point? L over 2. Okay, is there anything else? Nothing again, Shebi? That means I've pointed all the forces to this one. Why I'm not including this is because it's my fulcrum. So please, how to do this kind of thing is, when you've mastered us pointing it this way, you know as you are practicing, you try pointing everything this way. Then if you are done with it, you try when you are pointing this to this center and when you are pointing this to this center. It's just that what it will take is a little time for it to give you the same answer. Yes. So if I know that I will notice they have something in common. They have cos here, they have cos here. Is it not true? And they have L, yeah, L and L. Is it not true? Check now, yes. And what this thing means is that, let's say I have L here over 2. This one is the same as L over 1, is it not true? Yes. L over 1. So I can say L, get out. So that you know that this, if I cancel this, this becomes 1 now. Maybe? So that I now have anything divided by 1 is that it. So I now have, I don't know if I can do this here, let me continue it. As to, you said, why didn't you two cross over, Shemi? How? Throw lights, and I'm not in your brain. Throw lights, so I understand you.
Some of the how you understand those things.
Hey, Zachariah. Now see, if I'm going to be doing how I said everything at it simply means that I will be going back to the derivation. What we said is that once you stop, have it in mind that, for example, if I'm looking at this ladder now, this thing now, if I'm putting that FW, this ladder and this FW, they are not at 90 degrees. Is it not true? Yeah. So I will be putting it in a position whereby I will be able to make this force to rotate at 90 degrees. And the only way I can be able to do that is to come and say, let's say I have a force this way for this. Or let's say I have a force for this way. Because this force will be parallel to this force. So when you check it now, you see that if you pull this ladder out now and pull this now, it's giving you something that looks 90 degrees. So this is the only way I can do it. So please, go back and check our video on how to get angles to be at 90 degrees. You've not watched it. And one thing about students is that when you say these things in class, go and watch. They are too relaxed about it. But when it comes to class, they not wake up to it. Go and check how we derive forces. Taking force to 90 degrees on an inclined plane. That's our first class. This small thing on it is the second class. But if you can't remember it, we now gave a shortcut. Now instead of us stressing ourselves to do all those things, that once you see that force, it's on the x-axis and you are looking for the torque. Simply know that x-axis is simply anything you have here, attach sign to it. And for y-axis, anything you have here, that is FW now, attach cos to it. So inclined plane is simply the opposite of our normal way of finding vectors. Normal way of finding vectors is that we always point to y to be sine, x to be cos. But for inclined plane, you reverse it. Okay, so if that be the case, I'm now left with the reason why you see all these kind of things in exams is because they believe that if you do it over and over, you will master it. I have FFW cos theta plus FW. Shebi, please be checking for me. Sin theta is equals to mg cos theta. Is it not true? Now it's having 1 over 2. Is it not true? Times 1 over 2. So whichever way you put it is still the same thing. Now somebody wants to ask me, why didn't you cross multiply the 2 to multiply everything? Why I did it is simply because it's going to still be the same thing. Because when I start simplifying out, it will still be the same. So if I know that, I will check. I have cos here, is it not true? And I have cos here. It's easy for me to say cancel cos and cancel cos, but it's not going to be proper because this one is having plus. So I can say divide both sides by cos theta. Somebody say collect like terms.
Can switch cos. You can make FW sin theta. So therefore, can switch the other one to the other side.
There is a sentence collecting like terms. But I'm looking at something, I'm looking at a situation whereby I have this my sin theta turn to tan theta. See, let's say divide both sides. Let's say we say divide both sides by cos theta. Divide both sides by cos theta. It will still give us the same thing you're talking about. Yes, sir, because this time becomes FFW cos theta divided by cos theta plus FW sin theta divided by cos theta is equals to half mg, should be cos theta divided by cos theta. I will not be wrong because I'm doing it to both sides. So I will now have this get out. This get out. So I'm now having FFW, frictional force of the wall, plus FW tan theta. Should be? Because I have mg. Let's check. We need to be looking well, so we don't miss anything. Okay, yes. So that means I am left with FFW. Then FW tan. Do you know that the reason why I'm doing this thing is because I want to get to a point where I eliminate things. Now, if you notice that time then you simplify something, it's simply how do you break it so that you have a common path that gives you something simple, something you can look at. That's just what I'm trying to achieve here. So I'm trying to see if there's any way I can do this so that at the end of the day I have my theta pointing to something. That's what I'm trying to do. So then I have frictional force of the wall as an unknown. I don't know this thing. Is it not true? Then I have force of the wall, I don't know it. Theta as well, I don't know it. Even M that is here, I don't know it. The only thing I know here is G. Is it not true? So please, at this junction, we apply Newton's law. Is it not true? Or if possible, if we don't want to apply Newton's law, we can apply our equilibrium law, which is saying FW somewhere is equal to FFG. Is it not true? Or we say FFG is equal to FW. Then FW itself, somewhere is equals to this and this. Is it not true? Yes. So we can just go and check. So FFW, if we check, what is it equals to? Mg, what is it equals to? So it's more like I'm trying to see if I can substitute so that any of these can become my subject formula. That's what I'm trying to do. Or if possible, is there any way I can put Mg inside any of these things to make it subject formula? That's what I'm checking. Which one? Check all those things. Which one is easy for me to substitute so that it can take over everything? Eh? But yeah, see, let's check something. Let's check something. Inside Mg is equals to FFW plus Fn, should it? Yes. Let me replace Mg with FFW plus Fn. So my goal now, I'm trying to get a situation where I have forces. And see if I can cancel that. So I have half equals to, I have Fw tan theta plus, what about FFW? Is it equals to anything? Yes. FFW is equal to this, is it not true? Frictional force of the wall. So I can simply say, okay, let me replace this with FW. Which one? FFW. Is it which one? This one. This one. It's FW. I just brought what I have here down here. You need to be looking well. This one is frictional force of the wall. I see that. Yes, frictional force of the wall. Then I now check that inside the frictional force of the wall is equals to coefficient of the wall times force of the wall. Yes. And my Mg is equals to FFW plus. Yes, I'm not wrong. I'm not wrong. So, yes. Yes. So if I, yes. So what I'm actually doing is substitution. So this thing can multiply to so that I have half frictional force of the wall plus half normal reaction. Maybe is equals to FW tan theta plus coefficient of the wall times force of the wall. Hope you can still see the board. I've not done anything magic there now. The only thing I did is, okay, see, at this point when I cancelled out, we understand why I cancelled out, Shebi? Yes. Because I have considered here and I have considered here. Now I have unknowns. I have frictional force that I don't know. I have Mg that I don't know. And I have Fw that I don't know. Yes. But notice that everything we did actually started from that up going down. So let's say between this FFW, Fw and Mg, which one will I check there? Like if I check all those things I have, how do I make one of it subject formula so that it can accommodate everything that I have? And the only one that is proving that is just Fw because it's almost as if Fw is in everything. When I did Mg, I have Fw plus Fn. Now notice that somewhere for this Fn, I have Ffg over this. Is it not true? Which is still the same thing I have here for Fn. Now notice for Fw is equals to Ffg, which is here. And this is inside here. Then I go down again. When I did Ffw, I still have Fw. Is it not true? No. So it's almost as if what I'm trying to do is a situation whereby, okay, see what you do on your own. Forget the fact that I'm the one teaching you now. When you get to this point where you have a notes, how do you go about it? Because remember, they want us to get theta. The only way I can go about it is to find what I know now. So I'm using what I know. I'm checking for the things that I already have. I'm looking at all the questions I already have here when I started. That is, if you remember when you are the one that said you prefer when we do using upward and downward force. Then we do clockwise and anti-clockwise moments before we do torque. That is what we are using today. And remember that anytime we use that principle, we normally get, after we do that upward and downward, we say equation 1. Is it not true? Then when we come and do our torque finish, we now come and start doing substituting. So it's the same approach. We make all these things. We got all these things now. After we've gotten it now, it's now up to us when we are dealing with stock now to now come and be substituting into that our equations. These things are not like equation 1, equation 2, equation 3. So we're now checking the one that will correspond to the things we have at this point. So it's more like I have FW and theta. I have FFW. This FFW, what is it equals to on that our equations? The equations will derive first. You see that it's equals to coefficient of the wall and force of the wall. I replace it with that. Then I go again, mg itself. Check our mg. All the things we got for mg. What can take place of mg there? Shall be this one. I replace it. That is what I just did. So you see the same place. Each time, whether you like it or not, go and check if in that time we solve that question using the third principle. Anytime we use upward and downward force, clockwise and anti-clockwise moment, and then we do torque, we will always have to go and substitute. If you check even that time we solve that, we always have to go and substitute. So that is what we are doing now. Because our unknowns will be much. So we've substituted and we have that this is now coefficient of the wall, force of the wall times theta, then equals to half FFW plus Fn. And notice that Fn now, I still don't know Fn. FFW, I still don't know it. But notice that FFW here, is it not true? Is equals to this. Shall FFW here is equals to this. So I can still come here and replace FFW with this because I don't know it. So that I now have coefficient of the wall and then FW. See, if you don't understand, what you just need to do for me is, at this point now, go back to the equation, replace it with the things that is equals to when we derived our. Because notice that all these things we did here when we started, if you remember that our principle, anytime we do upward and downward force, we normally call whatever we have in equation 1, whatever we have here in equation 2, whatever we have in equation 3. No, notice that this one is from friction. So now go back to that should I say when we divided this point now. Substitute on your own now. Try to substitute. So that it's not that I'm the one teaching you. So that you see that what we are simply doing is that we are taking all those equations to replace inside the torque. Okay. Why did I to FFG? See now, I already have FW here. See that through? Then FFW is equal to FG. And is equal to FG. It's not, shall we? But it has FW inside it. That's why I'm using the FW. So I said that initially it's looking as if when you check this, it's looking as if that force of the wall, this one now, is what is found inside each of them. So that is what I'm doing. So you on your own, it's not us you are using what I'm doing. Because what I'm doing is I'm reasoning. You is using your own reasoning at this point. Using the equations we've derived. Try to substitute your own way and see what you have. Do your own reasoning. Because this is the point where all of us should stop. At this point, you're not applying your own way, you understand arithmetics. So at this point, I'm not saying, since I don't know this, what is it equal to that is equal to something that is common to all of them? And why is this way? It's because we are using alphabets.
What of FM?
What of? Do it now, not what of. You are doing the imagination and you want me to be the one doing the imagination for you. Do it, do something. And do it now, do. Let me see what you have. Do something, please. At this point, substitute. Let's see what you have. No? At this point, substitute. Let's see what you have. That's why we are learning. Substitute your own. Let me go around and check what you have. Substitute. Let me go around and check what you have. Because you know, it's not much to put it my own way. Me, I'm thinking of it in a way that I'm seeing that FW inside all of it. You now, if you're seeing FG inside everything you have there, put FG there, let's see what it give you. It will give you. Have you not noticed that mathematics is always, if I find something at the left hand side and I find it at the right hand side, it now becomes easy for me to cancel out. That's what I'm trying to achieve. A situation where I have all those things at the left hand side, I can now easily cancel out and say, thank God. So, if you do it in so many ways, it will still work for you, but we are in exam hall, so we are trying to use what will be direct. So try it, please. Let me see what you have. Don't use AI, you know. Some of you, once question is going on in class, your own is to rush to AI. So try, please, try. Let's see what you have. And do you know one thing about students nowadays? Your problem now is that every day you want everything to be the usual simple things you know. Yes. You do it that way, you go home, you're happy that you've learned. But guess what? That's why most of the time you enter exam halls, everything is looking strange. Yes. Because you are supposed to meet things like this. When you now enter exam hall, it's nothing. Are you done? If you are through, let me see your work. If you are through, let me see your work. Can I clean this?
No.
What about this side?
Wait, clean the other side.
Like, let me clean this side. Please be fast. I want to clean this side. Do you know why I don't want to clean this side? I'm looking at my components from here. So that's my guide. And know that once the wall is frictional and you use this method, use my method, you always be correct. And this method is actually not a particular method. It's something that if you learn it, you see that it's the same thing for everything you're doing. So I'm not doing that. I want to clean this thing, this part, so that I can start from here, from the beginning, so that we'll do it together. So I'm not the one doing it, you are the one giving me now. See, Shebi, I don't know MG. Do I know MG?
No.
Of all the motions I derived there, what is MG equals to? Please look at it very well before giving me. F what? FFW plus FN. Is it what you have?
Yes.
Now, do you know why I'm doing this thing now? I have MG here. But I have force this side. I have force this side. Is it not true? Remember that this one is weight. So I'm trying to see if there's any way I can have the same things this way, the same things this way. I will cancel out. Because what I have, there are so many unknowns already. So you've given me this. I will write it. It was, now, I have, looking at this, I have FFW. And I have FM. Please, let's the noise. Somebody's talking, let's the noise. Now, this place that I have FW, let's check there. I have FFG. Okay, sorry, check for me. What are the things FW is equals to there? FFG. One. FFW. I have FW and FFW, Shebi? Yes. But let's say I put FFW here. And what again? Plus what? What about what? Like this? Okay. Okay, then I will now have consider Shebi. 1 plus, I have this. Okay, what is FFW equals to them? Coefficient of what? And FW. Shall we see that what we've done here is that we've removed the rights from right, put it in left. Are you not seeing? Because here then I have FFW equals to this. Is it not true? Now, assuming I still allow my FW to remain here, it simply means that I've gotten to that point where I can easily cancel, and then check if there is a way I can make FFW to be equal to FW. So if you, as you are solving your own, you are able to find a way to take back this FW that is here, which means you are doing it twice. This FW that is here, I replace it with this again. You see that it's long process. you definitely get to the same answer. So that is why when I said FFW to be equals to this, I allowed my FW to remain. Because I already know that this one will give me that FW that is inside it. And notice that what I have here is also inside here. So whichever way you want to go about it, you still get the same answer, as long as you are able to replace and remember to continue replacing. Or you don't want to replace and replace and replace in a way that you not get confused. So I am seeing FW here, and I'm seeing FN this way. Now check for me. FW is equals to this. What about FN? Because I don't have any value for FN now. So I'm trying to see if there's any way I can get what I have here.
SMG
FFG over coefficient of G. And what about this one? Is the settle with this. So I can replace it with. Now everything multiplied by half. So now equals to FW tan theta plus. So if you look at this thing very well, you see that it's looking like something that you don't even have to follow this procedure. You can follow any procedure, but just make sure that you are not running around too much. That's what we are avoiding. Because we don't have the nodes. So now that I have FW this side, I have FW this side. I also have FW this side. Is it not true? That means I've achieved my dream in a way. The only thing that is remaining for me, yes, the goal, not dream, the goal. The only thing that is remaining for me now is this FFG over UG now. That is coefficient of friction on the ground. Is there anything that has to do with FFG with FW? Yes. Check. Notice that FFG is equal to FW. Is it not true? So I can easily, if not copied, I want to place this side too. So please, as you are doing this thing on your own, you can be trying it, rotating it different ways to see if you get the same answer. You will see that by the time you finish, you get the same. So FFG somewhere is equals to FW. So let me just replace FFG with FW. So all over coefficient of friction on the ground plus FW. But when you finish running around, you will see that what I'm doing is actually, after trying it out, and I found out that this is even easier. So instead of you running around too much, somebody said only one question. Yes, now the learning is always looking as if it's plenty, but when you learn it, you've learned it. Is it? Don't you know that physics is like everything you do in real life? Even when you are starting, they tell you that static friction will always be higher than kinetic friction. Because you starting it is always looking high. But once you learn it, it's go. So I have coefficient of friction of the wall and then force of the wall. Now see that I've achieved my goal. So I now have FW. So if you are the type that like things your own way, you are able to get FFW on both sides or MG on both sides, no wahala. But me, after studying this, I discovered that even without, it's not possible to get that FFW for all. But here, using FW, you will get it for all. You'll find that all of it is containing something that relates to this FW. So once I'm able to do that, it's not bad now if I say divide both sides or cancel out FW. So that this, and this can get out. I know that once I cancel this becomes 1, should it? So I'm now having coefficient of friction of the wall plus tan theta is equals to half coefficient of the wall, should be? Yes. Plus, if this times this, it becomes half, should be? Yes. Hope you agree. Yeah. Because if I have half, should be, times 1 over, you see now what it is? Yes. Should be, that's what it is? It is. That's why I have that. So because I know that some students, there are people that, once they are going with this, they are somewhere doing, That's why we normally tell you eat before coming. Ask your question before we progress. Is it this one? This one? Okay, this one. Okay, it should be under.
Yes, sir.
Are you sure?
Yes, sir.
Okay, let's check now. Let's check. I have, please pay attention, watch. I have 1/2, Shebi? Times 1/UG. Is it not true? Okay. Okay. Okay, it's supposed to be 1/2. Yes, now. Because 1 times 1 is going to be. Then I have 2. Okay. Am I correct? I should be correct now. I should be correct. Do you know the problem I have with my students is that sometimes, because you are sitting down, I'm standing, I believe you are the one seeing the board more than me. Yes, now. Numerator should multiply numerator. Denominator should multiply. Am I correct? Alright. So please now let's check. If I want to make tan theta subject of the formula here, what do I do? If I want to make tan theta subject of the formula, what do I do? So I have this and this, they are the same thing. Shall So this will not become the same thing as saying tan theta is equals to half coefficient of the wall minus coefficient of the wall plus. Is it true?
Yes.
Please be looking well,
Yes.
so we don't make mistake. I am using LCM. Using LCM, I should have that this is all over 1, Shebi? And this one is all over 1 punch for me. If the LCM is 2 here, is it not 3? Which is the same thing as saying minus. Shebi? And this is the same thing as saying half minus coefficient of the wall. Or minus coefficient of the wall. Is it the same thing you're having? Yes, now. I have this minus this, I should be having 1 now. So minus, and this is 2 now. Yes. So this is the same thing as saying half, or you say minus. Yes. So plus. Is it? I should do what? I have checked. I you subtract for me. If you do this subtracted by this, what do you have?
Minus.
And? Wait, so let me clean my own. You are sitting down. I do for me. By the time you do half, I am minus, what do you have?
Minus. UW whole divided by 2.
Shebi? Yes. It's the same thing I have now. It's the same thing as half. Because when you are doing this, some people with side talk will be I am plus
1 over 2.
I am. Notice that because they are not the same thing, I don't have to add. Is it not true? And this is the same thing as saying. Should we know it's the same thing?
Yes.
So tan theta is equals to this. So please, what you not do for me is, I think they gave us this,
Yes.
Check. In the question they gave us the coefficient of friction on the ground. And they also gave us coefficient of friction on the wall. So when they gave us coefficient of friction, he said,
And the UG is better. 1 over 2 UG.
okay, 1 over 2 UG.
Yes.
That is half UG.
Yes.
Sorry. I will got it here. So I'm going to be having 1/2. Well, let's put it this way. Then I have my. This is correct, right? So I have 1/2. I have what from it? UG is what? 0.45. UW coefficient of friction. 0.35/2. What punch for me? So please, as you're doing this, be paying attention so I don't miss anything. Pay attention. Is it 0.45 we have for this? Yeah. What punch? 2 times 0.45, what do you have? No, give me 2 times 0.45, what do you have?
So,
You've not copied that?
yes.
So I have tan theta is equals to 0.9 and
1.111.
do for me, see, do for me. 2 times 0.45, then do 1/2 times.
That is 1.111.
1. Okay, minus 0.35 divided by 2.
0.175. 0.175.
0.175, okay. But do 1.11 minus 0.175. So people are not even with calculator.
9.5.
Like this?
Yeah.
Okay, tan theta now is equals to this, are you aware? Which means that if I want to get it out, the process by tan. So theta is now going to be equals to tan inverse of 0.935.
43.076.
0.08. You said? No, that's the answer. Did you see answer there? That's the answer. Check out the one that sends the question. Okay. Do you know the problem with students? Your problem is that, like, I don't even understand how to put it. Now, see how it goes. If you think that's an answer, you solve it. Because I don't understand that negative energy. Please, what we've done here is something that if you look well, we only apply that FW to go through. So if you notice that FFW can work for you, you go through with it. Okay. Is it? Here. This one. Okay, guys. See that I have tan theta and I have this. I want to make tan theta solid of the formula. Okay, this one, how I got this answer? This one. Mbadu, should be this thing and this thing they are the same. Is it not? I am trying to do for me. If this is UW, it's going to be divided by 2, is it not true? And this one is being divided by 1. Anytime I have something that is in fraction, the only way to get the answer is by taking the LCM. So I just need LCM. Yes, that's all right. Yes, this one. Yeah. Do the LCM now. Do the LCM of this. See, do half, do UW/2 minus UW/1. Do the LCM, see what you have. As I'm teaching physics, I'm teaching maths as well. Because You should go home and revise this thing. You see that it's not hard. Why it's looking as if it's hard is because it's the first time. And you are the one that said we should be making use of the three principles. Anytime we make use of those three principles, we must substitute. Anytime we make use of those three principles, that is, anytime we use force up, force down, force right, force left, when we do the third, we must substitute. It's a must. So for those of you, you know we're doing it simple when we move from top to this way. Some persons felt this way should be better. Once you are using this, have it at the back of your mind that once you are using those three principles of equilibrium, you must substitute when you get to the top. So let's try to now use what we know now to solve the question we have from yesterday's class. Yeah, so when we're done with that, we can now go home. You see, we can now go home. 2:45. I got it, like I said. Can I clean? Let me clean this one. Okay, this side. So when I swear make use of my three principles of equilibrium. But this time around, when we make, we're not calling each one equation 1, equation 2. Things that are nicely here. Okay. When we do equation 1, equation 2, equation 3. So that we'll not forget. When we come back, we'll not be able to put it. So please read the question for that yesterday.
Let me see.
Yes, correct. Read question for yesterday's class. So remember everything we are doing today is linear ladder problems on frictional wall. Assuming there is no frictional wall, assuming it's frictionless, no need including that part. Going on. Bonnet, this one. Okay, please read the question. A uniform ladder, of mass, 2 kg, yes,
And then
2.0.
and length,
and then 5
yes,
against is 2 frictional
against a smooth frictional wall,
The ladder
the
is so that base and arm. With your rough or with your rough low.
okay, with the offer, okay.
The coefficient of that
Is the coefficient
0.85.
Okay.
How small can be?
Can theta
Be. What? What is that?
before
What is that?
the ladder begins? Is that all? Is that all? Okay, the question is a uniform level of mass 2 kg and length 5 meters leans against a smooth frictional wall. The ladder leans so that it makes an angle theta with the rough floor. If the coefficient of static friction is 0.85, how small can theta be? That means here and dry here with theta for the angle before the ladder begins to slide. Okay, okay. But let's try to look at it. Let's try to look at it. So you see that it's the same principle with what we used here that we're going to apply here. The same principle. The same principle. That is one thing about physics. The only problem that makes you look as if the formula has changed is maybe we did not understand it well. But you see that it's the same approach that we're going to be using to solve this. Just that thank God they gave us certain things here now. Wow. Every time, this is how I convert my hanky to duster. So you see I'm using my hanky to clean book.
That's nice.
You will not even know, you just convert it. Okay, see that you told them. Eh? This way you're pointing at. Okay, let's start. A uniform ladder. Let's say this is my wall. Now let's say this is my ladder. If I join these two, you will notice that I'm not doing anything strange. Nothing like maybe we do something that is new. So pay attention so you add to the understanding. Angle with the rough floor. Let's say this is theta. They always tell us that the angle is with the rough floor. Let's say this is theta. What force will be acting here? Normal force, should we? We call it Fn. Please, it's important that if we are doing this now, we pay attention to forces and weights. We pay attention to forces and weights. So if something is acting downwards, we don't use force for it, rather we use mg. It's important. So that it will lead you to knowing if there is something to cancel out or not. Okay. Then I know that if this is this wall, friction, since it's a frictional wall, the friction will be going this way. Is it not true? I'll say that this is frictional wall. If it's frictionless, the problem, there's no problem now. Should we do frictionless? It's frictional, right? Yeah. If I wanted it to be frictionless, or maybe it's frictionless, we won't have to even stress for frictional. But if you go into example and see frictional force, frictional wall, there will be problems. So yesterday, everything we did yesterday is for frictionless. This is for frictional. So this is going to be frictional force of the wall. And this is going to be the force of the wall. Very important. Okay. Now, there will be friction on the ground. This one will be frictional force of the ground, Chebi? Very important. And the weight of the ladder will be acting from the center towards downwards. Is it not true? Yes. And we say that this is the setting as what? Mg. Very important. Mg. Okay. Is there any other force that we are not touching? Check. So the next thing is now apply equilibrium. So we'll say upward forces must be equal to downward. So what are the upward forces? And which other? Fn, Chebi? What about our downwards? Mg, right? Okay, which means that FW. Okay, FFW, sorry, yes. So which means that FFW plus Fn should be equal to Mg. Do you agree? Yes. Okay. Now, this way, parallel force or anti-clockwise and clockwise. Which force will be going this way? FFG, right? Then this way is FW. Any other force? Just these two. Which means that FFG will be equal to FW. So we can say that this is equation. We can say that this is equation. Very important. Very, very important. But notice that what this thing means is friction. And this one, what it means is friction. Is it not true? And we know that frictional force is equal to coefficient of friction and so I can say that this frictional force on the ground is the same thing as saying coefficient of friction on the ground then times normal force, that is Fn. So that means I can call this equation 3. Then frictional force of the wall should be equal to coefficient of friction on the wall, then force of the wall. Is it not true? If you like, call it normal force. You are doing it yourself. We are always pointing friction to the force there. The force is there. Notice that this is the friction that is on this wall. This wall itself, this is the force that it will be given to this ladder, sending it back. Is it not the same thing that normal force does that this wall is doing by going this way? Normal force, you are standing because you are going this way, is pointing you back upwards. Now, because this ladder is resting on this one is pointing you back. So instead of normal force here, what you have is force of the wall. So if you go and misplace it, now you know. So this is going to be my equation 4. Very important. Very important. So I've noted all these things. Now the next thing I need to do now is to get my torque. So to get my torque now, I will simply say sum of torque will be equals to 0. Or clockwise torque will be equals to anti-clockwise torque. And anytime I'm getting torque, I always have a fulcrum. So since I'm making this fulcrum, what of this? Whenever you have a fulcrum, it simply means that you are imagining all these forces rotating towards this side. That is, you are imagining so that it maintains the balance. It's just like you have this thing and it's standing here. When you are checking this force, now you're imagining how will this force, if you want to go this way, this force will want to drag it upwards. Is it not true? So that it doesn't fall. So if this thing is rotating this way so that it maintains the balance, if this is rotating this way so that it maintains the balance, that is what you imagine. But the fulcrum itself is not going to rotate because this thing that is here, even if it falls down now, you see that it's going to be on it. Is it not true? The force that is here actually on this hole is not rotating. What is rotating is the force is on this end. So that is what we're trying to imagine when we're saying that this is the fulcrum. So we're saying, how do we make this go to this part? As it's going this way, you see that if it's going this way, there will be balance on this. That's what it means. Now this one that is this way, if it's going this way, the weight itself naturally, this way is going to be acting. So if it's going on this fulcrum towards this end, that's this balance. But this one, no force. So we are taking it that this one, there will be no force. So if as you are solving your own, you want to put your fulcrum here and do it, no one has. But me, I'm used to the habit of pointing my forces downwards or this way. So when I'm doing this, I normally point this towards this end because of the fact that I am seeing this force of the wall and I'm seeing friction on the wall. And the reason why I'm even solving this question this way is because of the friction on this wall. So I'm making it that I'm giving reference to what I have here and not what I have here. Nobody asked me for friction. Actually, this friction on the ground is here. I won't have to do this. But the reason I'm solving and adding this force is because of this. So I want everything here to be visible, to show it. What that is. But if you still point yours this way, you will still get the same answer. But I've not done it. So I'm used to this, pointing this way. And I'm used to pointing to right for this and to right for this. So if you point this to this way, you should get the same answer. If you still remember, that time we solved in class where we pointed all our forces to this side and still pointed to this side, we were able to get the force of this and the force of this. Is it not true? Notice that these are the forces here. And if I'm pointing this to this end, what I'm getting now is just this and this. Notice that I'm no longer getting my FW. I'm not getting my FFW. And remember, we're going to get it as well. So I'm pointing down this way. So whichever way I'm doing it and elaborating this way is that as we are trying a particular method, you can go on and try different ways. See if you can point your own thought to the other end and get the same answer for your theta. So if I know that doing my thought now, I'm going to be having FW. And whenever I'm having thought, I'm taking it that I'm using the components of this that will give me 90 degrees. Because notice that if this is my ladder, and I have this FW going this way, what I have is up to 90. Is it not good? So how do I make it? Now notice that there must be theta this way. This line is parallel to this line. Are you aware? Now, if I'm taking this particular thing now to y-axis, is it going away from the angle or towards the angle? Yeah? See, I have this. Watch it. Let's be sure what we're doing. I have this going this way, and this is my theta. So, am I opening that angle? And away from the angle, we use what? Towards the angle, we use what? That is not looking right. Because that thing is supposed to be cos. Is it not true? Is this sign we're supposed to use?
On the y-axis, we're using sine.
No, now, for inclined plane, we use cos for y-axis. Is it not true? So look at it well. What is missing? I think our problem is from here. Where we rotated this. I think that's where our problem started. If you like, as you're doing it, don't be thinking on your own. Stop waiting for us. I have this. I have this. I know where I'm coming. Okay, please see. I said no. I don't leave until I finish what I started. See. We have seen that here, Shebi. I remember that our business is to make 90 degrees now. Is it not true? So we should be taking this to this point. So that I have this already, is it not true? Taking this to this gives me the 90 degrees. Shebi? Yes. So when we took it actually to this side, simply means we have 90 degrees, we are taking it to 0. Shebi, you see? So it's supposed to be, as I have this way, and I have this, how do I take this to this point so that I get 90 degrees? So I'm going towards the angle should be what? Cos ahead. So we are correct. We must be correct at all times. That's why you're science students. Alright, some people's problem was right, let me copy. If you like, don't be part of what we're doing. It's a science class. Alright. We are now looking for thought. So I want to clean the question. Can I? Thought talks about product of force and perpendicular distance. So when we are rotating this top, we are checking how do we make those forces to be at 90 degrees with that ladder. That's what we are doing. So if you don't want to do it that way, just check the video we did on finding force on an inclined plane or linear ladder. You will see how we derive all those forces. So if I have that, I will simply say, instead of testing myself, I will say 6 FFW. Since FFW is already on y-axis, let me just call it FFW plus theta. If you don't want to stress yourself deriving it, just say, since it's on inclined plane and it's going vertical, just add cos to it. Now, what is the length from this point to this point? Okay, and L is 5, shall we? Yes. Okay, plus, notice that these two, they're always going in the same direction. So FW, you can give us our FW in the question. So I'll just say FW, since it's going vertically to what? Sine theta. Then, and notice that it's the same length, shall we? From this end to this end, and the length is 5. Okay, is equals to, because this one is going this way clockwise. Going clockwise. Clockwise must be equal to anti-clockwise. This is the other force pointing this way. So equals to mg. And it's going vertically down. Anything vertical, attach cos to it. Then okay, n over 2 half, shall we? 2.5. Is there any other thing? That's all. About everything that we have. Okay. So at this point, it's looking like something we know. Yes. So we have 2.5, we have 5, we have 5. Okay, wait. Give us that the math is straight 2. Okay, that means here now will be. Okay, so M, the mass is actually 2 kg. So that means that the weight mg will be 2 times 10, shall we? Which is equal to 20. Well, let me replace this with 20 newton. 20 cos 2.5 equals theta. Okay, yes, we don't have theta already. Yes, 2.5 is good. My point for me, 2.5 times 20. 50, shall we? 50 cos theta. Is it what you have? If you like, don't participate. Stay and be doing it, when I get home, I will read it. Don't participate. So I can say, okay, let me just bring everything down first. Are you not noticing that it's the same thing we are doing?
Yes.
That's the same thing. So when you master it well, few minutes, we are done. Oh yeah, now do for me. See what you do for me now. At this point, 5 can go here, 5 can go here, 5 can go here. So what? If 5 go here, cancel. 5 go here, cancel. 5 go here, what? I now have FW sine theta plus FFW cos theta. Thank you. Before students are saying the next step, giving me the next step. So I'm dividing by cos theta. Each time people give answer, there are people that their hearts normally fly. They'll be wondering how come. So this cancel, this cancel. So now, Shebi? Cos theta. Very simple. So you see that at this junction now, we are now having unknowns. See what we can do. We now have FFW that we don't know. Shebi? FW that we don't know. These two we don't know it. Notice that it's easy for us here because thank God they gave us MG. Shebi? Thank God. So I shouldn't. The other one stressed us a bit because they did not give us the MG. So thank God this one they gave us MG. So no need stressing again. It's just these two we are looking for. So you can see that simply we can just go and look for FW. FW is equals to coefficient of the wall and force of the wall. You see that too? Notice something. FW is equals to FFG. Shebi? What something? FW is equals to FFG. Now notice that FW, if you make it FFW here, if you make it sort of formula, it still doesn't have anything like FW inside it. I'm talking about this FFW. Now, watch this FFW. Notice that if I have FFW, inside it I have FW already, immediately. You see that too? Yeah. Immediately. So that you see why I'm going to use what I'm using. But watch for FW itself. FW is equals to FFG. If I make FW such a formula here now, it still has no business with FFW again. So I'm going to just replace this one. This is the one I'm going to carry and replace so that I now have coefficient of the wall and then FW plus FW and theta equals to 10. What we are doing here is not like magic. We are just using the principles of mathematics. How do I make everything to be the same thing? That thing you normally do, substitute this one for this one. That's just what we are doing. And once you've learned it, you see that it's the same. You are flowing with it. So then notice that at this point, I have my coefficient of friction of the wall, then I have FW, then I have FW tan theta. Remember that my goal is how can I make this tan theta subject of the formula? So that I will not make theta equals to. So I think, okay, let me just clean small this part, you've written this now, and I don't think we have any business, okay, I'll just clean this part, because I might have need for this, so that we don't complicate things. Alright, so I now have that this is going to be the same thing as saying FW tan theta is equals to 10. If that one crossover becomes coefficient of the wall, Shebi, and force of the wall. So minus this. Okay. Did they give us, first of all, did they give us this? Did they give us this coefficient of the wall? Okay, we will still come to it. Now notice, remember that my goal is to make tan theta standard of formula. So okay, so this will take care of this. So that I now have tan theta is equals to 10 over FW minus coefficient of F. Okay, sorry. This will take care of this. Okay, minus coefficient of the wall. Okay. And remember we don't know FW, Shebi? But notice that we know, did they give us friction, coefficient of friction? Which of the coefficient of friction did they give us? Is it this one? That is for the ground, Shebi? Okay. That means that I can actually turn this to this. Sorry, to this. So that from here now I can be able to get this. Do you remember? So I can now say that this is the same as saying up to this point are we following? Because yes, now see, notice that they did not give me force on the wall. Then did they give me coefficient of friction on the wall? No. Check those. No. They did not give me. Read that part, let me hear. Coefficient of friction flow is what? 3.35.
85.
85. Is that what they gave us?
Yes.
Wonderful. Okay. Okay. So I'm now asking tan theta is equals to 10 all over. Let me replace this with this. Yes, so that I now have FFG. And FFG is going to be presenting as this. So I'm going to be having an Fn. And Fn, if you remember, if you make Fn solid of the formula, Fn should be giving you FFG over coefficient of G, should be? And remember that FFG already is equals to FW. Should be?
Also, you can make Fn equals to Ng minus FSW. Then the FSW now substitute and UWF
No, there's no money there. See our problem. When we read this question out, we did not give ourselves the coefficient of this word. Because that's what is holding us back. Notice that the last one we solved, we have that coefficient. That's what is holding us back. Holding us back. If we don't solve it, you know what you're solving. You will still use that first approach now. So I'm looking at it and I'm telling you, see, this one, I notice that this becomes easy when we substitute, that this is simply mu G and Fn. And Fn is going to be set as this, all over this. But notice that we don't have this. Somebody said we'll find it.
So there's nothing that we can solve.
No, calm down. Yes, I noticed that the last one they gave us coefficient of both. Okay, so please let's take coefficient of friction of the wall to be something. Yes, now our coefficient of friction should be there now. So if it's not there, that means what we are actually going to be having is simply 10 over FW is equals to FFG. Shall we? That is this. FW is equals to FFG. And FFG is equals to this. Is it not true? Yes. So if I replace that for FFG and I have minus coefficient of friction on the wall, then if I'm making theta solid on the formula, I want to clean. So if somebody says let's leave it solving like that, so you don't look as if I'm using a manual to generate. So what we are simply going to have is that theta mu G, then Fn minus coefficient of the wall. This is what we have. That's the final answer. So because, take it now, take it. You know I'm the one that actually gave you that particular question, this particular question we are solving. I'm the one that read out the question for you now. Yes. So we are supposed to be giving that our UW. So your situation is not giving to us. That means we're having tan inverse of 10 over coefficient of ground friction, then our normal reaction, then our, and please, somebody wants to ask me what is normal reaction. Notice something. If I have that this is my normal reaction, notice something. The weight of this towards this graph is what? Empty, shall we? And we got it to be what? 20 Newton. Which means that up here, what I'm having here is as well 20 Newton. But there's no need putting that because we are not giving this. So this is where we are stopping for this question. We are not wrong because I've checked if there's any way we can make UW subject of the formula for this. And I'm not finding it. This is a science class, are you aware? So please, everything is not about you copying. We need to be looking deep to see. So see, no matter how we do it, you are still stuck. See, if we have that FFW is equals to coefficient of the wall and friction and force of the wall, if we do divide both sides by force of the wall, you will see that we are now having FFW over FW because this will cancel this. Is it not true? Now let's say FFW, we still put it back. This is now going to be the same as force of the wall, coefficient of the wall, and force of the wall. If you put this to this, will cancel this. You are still left with your UW. So there's no going forward with it. There's no going back with it. This is our final answer. We're not giving the coefficient of the wall. That's our final answer. No matter how you do it, no matter how you go about it. But can we just take it that our coefficient of the wall is something? Because notice that even the one we solved, they gave us coefficient of the wall. So let's take our coefficient of the wall to be something. Once we have that, we are good to go. So let's say that coefficient of the wall is equals to 0.35. Because you cannot tell me that there is friction on this and not give me the coefficient of the wall. So let's take it that what I have here is 0.35. So if it's given, we've solved it. And without replace. So let's now use it to work this. So please, you can now say in that your question, take this to 0.35. For those of you that will be saying we are doing a manual, when you go home, check if there's any way they will give you a frictional question without giving you the coefficients. It's not going to be possible. So go and check. If there's anything that will give you this, I think when I read this out using my head, I forgot to give out for this. Yes. So if I know that, I will now apply it so that I now have that this is going to be theta. It was the tan inverse of 10 all over. This one is 0.85, Shebi? Then times 20 minus. And now punch for me. Do for me. First of all, 0.85 times 20. Wait, everything. You did tan inverse of everything.
No, not tan inverse. I'm saying over this.
Okay, you did tan inverse of. So the other answer is what?
0.238.
0.23. Okay. Madam, do the tan inverse. This thing we are doing is correct. I know your problem is this. Please, nobody will give you friction without giving you the coefficient. When I read it out, I did not put that. It should be there. Something will be there for the coefficient of friction. So go and check if there's any frictional question that they will ask you without giving you the two. It's not possible. Alright, so please, if you do the tan inverse, what do you now have?
13.398.
13.398.2. Okay, and it's going to be approximately 13.4. What we know in degrees theta. So please, do you know when I gave you that question, why we are having only one? I was thinking in my head using frictionless. I was not considering this friction when I gave you that question. So I was considering only the friction that you have here. Yes, and remember that for any frictionless wall, we normally solve without this one. Is it not true? Why, when it's frictional, we always include this. So that's why I did not give that. Every frictional question must be given. That is, the coefficient of friction must be given. Check, you will see. Every frictional question, they must give you the coefficient of that friction. So it was not given, so it should be there, and we are correct. So you don't think maybe we generated to have an answer. No, we are correct. It's not man, it's correct. We should have a coefficient for our friction. Alright, so please, with that said, you will keep obviously or easily notice that this thing has just 3 rules. Find your equilibrium, that is for upward and downward. Find for parallel, that is left and right. Then when you are done with it, still remember what friction is. If you remember what friction is, then when you are doing the talk, all I'm just doing is pointing to a particular direction. So you are not limited to the direction you want to point to, but because you're in my class, I will advise you stick to this. Yes. There are some things that if you do, you see that you are going over to do the same thing twice. Yes, because I saw most of these things, I saw it over the years. So when you're pointing this towards this thing, once you are done, you check if there are more than 2 unknowns, you substitute. That's just it. So it's not hard. So please, this part I gave us issue. We are correct. We should have a coefficient for friction. Every friction must have a coefficient. Ask the question so we solve another question and go. Yes. This is 327. Are you okay? See. There is something you need to understand. Once it's tutorial class, I believe some persons even came to school today, but they don't know that we are here. Please, once it's tutorial class, our time is always 4, even normal days. So we have to just endure and deal with it. With time, it will master us. Even by now, it's supposed to have mastered us. Yes, I should do tell you to always eat before coming. Give you assignment. No, I will give you assignment on the group. But for now, let's check that. Okay, see, I think, let me use this opportunity to do something, to talk something. Do you notice that when we did vectors last year, we did cross product and dot product of vectors? Is it up to you? Yes. But this year we've not done that. You observe, Shemi? So let's talk about that cross product and dot product of vectors. Then we'll go.
So please, we can continue with this topic.
Okay, this one. Okay, I should continue with this topic. Yeah. You said? What you okay, what you get will not be in the option. How do you know you are getting it correctly? Are you sure? Maybe you know that there are sometimes you are very sure of something, but you need to look again. Don't worry, see what you are doing for me. That's why we are trying to hurry this. Because we need to come to a point where we start doing what we call marathon class. Marathon class is all about past question. That's why when Master Taka posted past question there, it will add to some person's confusion. Notice I deleted it. Yes. So in our marathon class, what we are doing is just past questions. So what you will do is be gathering those your questions that you are solving and you are sure. Yes, be gathering those your questions so that during marathon class, if we solve and it doesn't tally with your own, you now see what is missing there. If it's not possible now. Why it's not possible is because we have the time. Maybe you know. They say time is your friend and time is your ally. And thank God we have somebody like you here to remind us. Is it not true? Yeah, so during marathon, please go and get all those your questions so that we use it. In fact, do you know what we can do? How about we make Saturday, every Saturday for that kind of questions? Yes. So next Saturday, what you're doing for me, see what you're doing for me. What you're doing for me is, you are bringing questions on a particular topic that we've treated. So you can check all the topics we've treated, the past questions. So that's your job. You're the one that will be giving us questions every Saturday. Yes. So he's the only one that will be doing that because there are people that are not normal. When I say everyone will come with your questions, people can't believe they're down. So please make it stick to our scheme of work. Yes. From beginning to the end, just be checking the topics. Alright, so please let's touch cross product. And we are starting that thing where I'm telling you by next week Saturday, so you remember. See, if each time we feel tired, we go home. That means with time you'll be breaking hand in your tiredness up. So that maybe once it's one you get tired, you go. Two you get tired, you go. No. So even if you're tired, you have to make sure we are sticking to that particular course, the habits. See, I want you to look at this. I will go ahead and check. If I have A to be equals to
That's in 0.
yes, 0 K. I don't know. So you find me the A dot B. No, we are doing it here in class. Here in class. So I the A dot B dot C. And then I A cross B cross C. Yes. Then IV. The A dot A cross B cross C. Yes. So let's try to solve it. Okay, sorry.